My name's Grant Ronald, and I work at Oracle. I have a background in development way back a number of years, and I now am a part of product management team in Oracle, where we're responsible for the mobility and development tools within Oracle. So we build a number of products and stuff that hopefully you guys as developers are using day in, day out. In this session, I'm going to give you an introduction to some of our products and tools around and technologies around how we develop applications using Java as a programming language, but for iOS devices and Android as well. Just a quick outline, and I like to start gently. I'll just give you a brief introduction of why we're positioning these tools and technologies, where they fit in, why you might be using them. And I'm going to introduce you to one of our frameworks that we use quite extensively within Oracle as well, called Mobile Application Framework. And then I'll give you an introduction to the architecture that's behind that, kind of go underneath the covers. And then the bulk of the presentation, I'm really going to try and dedicate to demos, okay? So we'll try and give you an opportunity to actually see the runtime experience, the development experience, and you get a chance to ask questions as well. So, for those of you who are maybe, a quick show of hands, how many people are building mobile applications today, on-device apps? Okay, a few. How many building web apps? Okay, that's good. So, there's, let's call it 3 options you can consider when talking about building mobile applications. The first here, mobile web. So anyone that has a mobile device with a browser on it can access an application, and that's a mobile web application. Now, the huge advantage of that is, as a mobile application, you build one code line, and it doesn't matter whether you're accessing it from tablet, from iOS, from Android, Windows. It doesn't matter what device they will render, as you'd expect. The downside there is you're not really, as a web application, you're not really exploiting the full power of what you have on the device, things like GPS, push notifications, local processing power. So at the other end of the spectrum, we've got native development. So that's if you build native on-device applications on Android or iOS using the native frameworks and tools and languages. So those platforms, iOS, using Swift or Objective-C, and Java on Android. Again, that gives you the massive power of actually using the device APIs. But the downside is, essentially, if you've got to maintain 2 code lines, because you may well be deploying mobile applications of which some of your users are Android, some are using iOS. So with 2 different development environments, you've essentially got 2 code lines, double the effort. There's a third option you can consider, and this is something that sits in the middle, the best of both worlds, called hybrid. So mobile devices have a number of common technologies that are embedded or structured as part of those mobile devices. For example, HTML, JavaScript, CSS. Okay? So if you could build an application that utilizes the common features of each platform, like browsers, JavaScript, HTML, then you've essentially reduced your development effort in half, because you can develop once and use it on both platforms. So, how many people Java developers here? Fantastic. So what if, as a Java developer, you could develop applications running on Android, but also on iOS devices as well, something you maybe think you never could do before. Leveraging the same language that you know, the same architecture, the same design steps or goals or building blocks, MVC, component-based, POJOs, etc., then that suddenly takes your skills from maybe your server-side or web developer now becoming a mobile developer. And that's something we've been trying to do within Oracle, because we have many same problems ourselves. We have a huge development organization who build a lot of our business applications using our tools. So me and the tools division has got to make sure those guys as developers are as productive as possible. And we have a huge amount of Java development in-house at Oracle, as you can imagine. So our goal here was to build something in which someone who's a Java developer and familiar with Java as a language and the concepts of Java could build mobile applications just as productively. And so we've got a framework that, as I say, we use ourselves and also many of our customers do as well, and it's called Mobile Application Framework. And it's a hybrid. It's talked about hybrid. And it's a hybrid in that it uses essentially the browser, albeit, let's call it an invisible browser or a headless browser, to render the user interface logic. Okay? So that means that the user interface components and stuff can be common between Android and iOS because we're using that common element. The other thing we've done with Mobile Application Framework is we've embedded and created our own JVM inside the framework, which means that you can use Java as a programming language for your business logic. Now, just as a reminder that there's obviously business logic you put on device, but you'll also be accessing business logic remotely via REST services as well. And I'll show you some of this in the demos. The idea here with Mobile Application Framework is you can develop it once, and what you'll see me developing, and I'll deploy it to the iOS simulator. But equally, at the point you deploy is the point you essentially have the option of saying, I'm going to deploy to Android or iOS. Okay, so you're developing at one code line, one common set of languages, and it's only at deployment time you deploy your separate runtimes. So these are the kind of very brief high-level goals of what we're trying to achieve with our application framework. Build once, run iOS, Android. Simpler UI development. We have kind of pre-created a bunch of UI components, about 80 UI components, allowing you to kind of essentially drag and drop those components and easily bind them to data. So we've taken care of building the kind of nice widgets, the data visualization components, those things. Java is your scripting language, but you can also use JavaScript as well if there are particular extreme corner cases where you want to really maximize the benefits of the platform, then you could use JavaScript as well. A choice of development tools, I'm going to show you Eclipse, but we also support JDeveloper. Offline capabilities, SQLite database as well. So embed a SQLite database as part of the framework so that if you have to do offline caching of data or whatever, then you can easily do that as well. And we give you access to native features through the Cordova plugin as well, so that you can easily call out to things like the GPS or the email system or your camera, whatever you've got on your device. And although you'll not see much of this in the demo, because what I'll do is pretty quick and dirty, but you will see that what I create in terms of pages, page flow, bits of business logic themselves can be easily modularized and put into libraries and shared. Okay, so this is something, again, we're looking to work at a team environment. So the last 6 months or so, we upgraded the JVM in Oracle Mobile Application Framework to work with Java 8. Just so you're aware, and again, we'll talk about this in the architecture diagram, what we do is for every math application that you deploy to your device, this lightweight JVM gets deployed inside that application. For licensing reasons, we cannot deploy one JVM that is shared between all your applications. Okay, so what it does do is about a 16 meg download, or sorry, JVM that increases your download. In the great scheme of things, not particularly large. The components, what are called AMX components, application mobile XML. They're defined as XML, but those are your components ranging from the simple checkboxes up to more exotic things like maps and graphs. There are 3 types of content you can create in a math application. You can use our AMX components. That's the very visual, easily used drag and drop components. You can create a local HTML, so content can be local HTML, again, giving you the power to just do whatever you want with Java, JavaScript, HTML5, or a page or functionality in your application can also point to remote URL. So if you have some corporate web application that would be useful as part of your application flow, well, it can be remote as well. So you have a choice of the different development options for your pages. You'll see as I start to create some of these things, the various UI components. This is about 80 components. For the sake of the demos here, I'll be using some of the pretty basic stuff, text fields, buttons, lists. But as I say, we get up to some of the more exotic data visualization. And I'll try and drop in a couple of graphs there as well. The look and feel, again, is pretty standard out the box, but can be completely customized to your own look and feel using CSS. So you've got a particular corporate look and feel, and that's quite easy to apply that as well. One of the things that's quite a nice feature of the framework here and within OP and JDeveloper is we have this visual way of developing a lot of the application. And we have what's called a task flow diagram, which basically allows you to define or whiteboard out or specify the flow of the application really using a diagrammer. So I start at page 1, I go to page 2, and then once I'm on page 2, I could go to this page or this page. And so your navigation becomes a visual. There's a lot of advantages apart from the declarative element being a little bit faster than coding it. It also works quite nicely as a way of sitting down with your end users and kind of whiteboarding what the flow of an application looks like as well. And I'll talk more about this in the demo as well. We have this concept in Mobile Application Framework called a data control. What we're trying to achieve here is there are many ways you might define data. Okay, a data could be a POJO, it could be a REST service call, a SOAP service call, it could be a JDBC call out to your SQLite database. What our data control does is it provides basically a consistent abstraction over the particular implementation of a data or business service. Okay, so and you'll see this in the demo I do. The UI developer who's got to hook up a list to some data, employee data, isn't burdened with the fact I'm having to bind this to a REST service or a SOAP service or a POJO or whatever. It's bound the exact same way regardless. So your UI developer, and it might be the same person as the guy who's writing the business logic, but at least you're not burdened with having to get into those differences in how these things are implemented. And in this diagram, you can also see that we also expose the device features in a consistent way. So the way you would, for example, take a picture with a camera or send an email on the device is exposed through this data control palette the exact same way as your own custom business methods, like deleting a record or updating some information or whatever it is. Now here's the architecture diagram, and I might refer back to this, but just very briefly, the outside part here is what sits on the mobile device. And on the far right-hand side is essentially what you might have on the server. So REST services, remote REST or SOAP. It could be server-generated HTML if you want to have a remote URL page or something. But what gets downloaded onto the device is here on the large box. Now, we use something called the web view over here. I find the best way to describe the web view is like a browser with no Chrome, okay, like an invisible browser. And what we are essentially doing is with our AMX components is they're being rendered in HTML and JavaScript. Okay, so they're being rendered in a browser or a Chromeless browser. Behind the scenes here, we've got the JVM that's downloaded into every application as well. So if you've got business logic you want to execute or whatever logic within your application, that can be JavaScript. Java. We also have the option for writing business logic. Here's JavaScript, or creating pages which are based on remote URL. Here's a SQLite database, and we integrate with all the device features, camera, GPS, etc., through a JavaScript API called Cordova. Okay, so that's the 10-minute overview on what mobile application framework is. What I want to try and do now is give you an essence of what the development experience is like and the kind of things you do. Now, whenever I do these demos, I try to say to people, I'm not going to make you an expert, as you see what I'll do in the next 15, 20 minutes. But if you can take away, as I say, the essence of what we're achieving here and the style of application you can build. So here I'm in Eclipse with the Oracle Enterprise Pack for Eclipse, which has got the math extension included here. And let's create a new math application, and we'll call it for DevOps UK. Now, there are essentially two configuration files that would be of interest to you building this math application. The first one is called the math application.xml. It just defines high-level information about the app. Okay, so for example, by default, this application is going to be called Employees Dev UK. Okay, but actually on your device, if you wanted to call it, Employees or your company name, that's where you change it. As we create features of the applications, you'll see them here. Navigation defines what parts are features. And when I say a feature, I should maybe highlight, when you build mobile applications, what you can't afford to do is deeply nest lots of pages. Your application tends to be broken out into separate use cases, which appear as their own icons on the springboard or in the navigation bar. And those are called features. A feature would typically be a use case of 3 or 4 pages, something you can do in about 2 minutes. So here we can define whether the feature is shown on the navigation bar, whether it's shown on the springboard, how the springboard navigates, those kind of things. Security, if you wanted to require users to authenticate, then you can define what your authentication server is, information like that. So that's your math application.xml file. The real bulk of where we're going to do our development is down here. And there's a file called the math feature editor. This is where I say, right, I'm going to start building my application, and I'm going to build the application as a number of features. Remember, a feature is just like a use case of a couple of screens. So let's create a feature, and let's call it employees. Okay, and let's create another feature because in this application we might want a help system. So let's have a feature called help. Okay, now I'm going to add the actual content to that feature. So again, let's create new, and let's do an HTML file because our help system, let's just say, is going to be an HTML help system. So I'll create that, we'll call the page help, and there I can put in my help system. So for the sake of simplicity, okay. So that's one feature that's being created, which is a very simple local HTML page. It could be much more complex, of course. Here we'll create our employees feature. Now the content here, let's create, could be a single page. But remember I talked about a task flow, which is a number of pages. So let's create a task flow. And let's call that task flow employees task flow. You'd never realize how difficult it was to develop standing up when you're used to sitting down. Okay. Typos might not matter. So here's our task flow. So our task flow is essentially our whiteboard in which we will sit down and design the flow of the employees feature. Here on the left are the kind of things that can appear on this whiteboard. Now, the most obvious thing here would probably be, let's access a little bit more, is a view. So a view is a page. So let's have our first page, and we'll call it employees. Okay? So that's one page. Let's create another page, and I mentioned we might do a graph. So let's try a graph. So 2 pages. Now, I want to define the flow between these pages. Well, we have a control flow. I just draw a line and give this a name. Let's call it graph. So what you can see now is I'm starting to build up the flow of the application, which is pretty simple. I've got an employees page, I've got a graph page, and I can navigate from one page to the next. Okay. If you look down here, apologies who might not see, there is some of the other things I can use is a method call. So, for example, in navigating from this page to this page, I might want to first call a Java method to do some stuff, maybe create some blank data or query something. I could drag in a method call, so essentially just dragging in a Java call. I could call a task flow call, so that's a call to another task flow. So if someone in my team had built a checkout task flow, I could say, well, at this point, I want to call that task flow. And we also have something called a router. So it might be, depending on if you're a manager or just a regular employee, you will either go to this screen or you go to this screen. Okay? But we'll keep it pretty simple at the moment. Let's save that. So let's go in and actually create those pages. I haven't actually created the pages yet, hence the little traffic symbol there. Let's create the employees page. And I go into my XML editor here. Now, there's a couple of things. We've got a title at the top. So let's change that to something more meaningful. Here we've got a button. And a button has properties. And if we go down here, you'll see the properties buttons have. And one of the properties is text. So we'll say graph, because pressing that button, I want to go to the graph. And the way I actually do that navigation is there's something called a button action. I could call an action listener, but if I click here, you get a list of any flows that are on the employees page. So I get to choose. So at the moment, there's only one, so it'll be graph. So I'm pressing that button there. I will navigate to graph. Okay? Let's create the graph page. Let's make it a simpler layout. Finish. And again, let's just change the header here. And in this button, we'll make it back. That'll go to the previous screen. And the button action is, and we actually create, by default, a back action for every view that's on the task flow. And this is pretty neat, because one of the things it does do is if you get to a page via many different routes, it works out where you've come from, so it will take you back to the right place. If you explicitly want to move somewhere else, then you just create your own flow for that. Okay, so that's me created 2 features: help, employees. Employees is made of a task flow of employees and graph. Okay, so we've made some progress. Now, we want to start maybe adding some business logic to this. Now, I've talked about, the whole title of this presentation is about developing with Java for iOS. So I'm going to create some business logic in Java now. So let's create a new Java class. Let's call it employee. Okay, and since no one ever wants to watch me develop code, I'll just do this. Okay, so what I've really created here is an employee data object, name, email, salary, and a bunch of getters and setters. That's all I've done. I'll create another Java class called employee. Let's see what we call it. Employee service, which is essentially my kind of service interface or facade. And in here, again, if I just do this and do all I've created is this is my service facade where I actually populate a bunch of employee objects. Okay. So nothing too earth-shattering yet. Now, having created these two Java classes, remember I talked about this concept of a data control giving me a consistent abstraction over my business service. Well, this is where I'll create one of these data controls now. So if I do, and run here, model components, create data control. That will create a new data control. If I do finish. Okay. And here is my data control. Here you can see a collection of employees, and there's the attributes within employees. Now, how does that help me as the guy who's building the user interface? And this is where it does help me. Let's go back into the employees page. Now, if I look down here, here are all the really nice visualization components I talked about. And some of the nice components, attribute list, etc. Now, I could build the page up by dropping on UI components and then bind them to data. But the other way I'm going to do, and this is which is quite nice with this concept of the data control, is I can actually choose the data and then drop it on the page, and then OP will say to me, okay, which components do you want to use to visualize that? So here's how I do it. Here's my data control. Here is, and again, apologies for those who are maybe on this side of the room, I'll keep talking about it. Here's my employees data object there. And I can just drag that on to the page here. Let's drop it here. And I now get the option of how do I want to display that? Well, let's display that as a list. And I get to choose what kind of list. Let's do something like this layout. The main text, and we'll drop in. So that's the employee's name, and it will show the email. I can also divide this by name and first letter. Okay. So in my employees page now, I've bound that employees Pojo to a list. Okay, so that's the first thing. Now, just to show you one of the neat features of this data control is, let's take this exact same data on the graph page, so exact same data, but this time we'll visualize it differently. Okay, that information we'll visualize as a bar chart. Again, let's pick our component. And because there's a standard interface, OP knows how to look and see what data it needs to pull out and how it presents it to you. So you need to present a bar, basically your X and Y axis. So my Y axis is going to be salary, okay, and my X axis is going to be name. Okay, so if I was sitting at home doing this, I would probably run and test it, okay? But I don't know about you, but it takes about 3.5 minutes for the simulator to pop up and populate it. And I'm not going to talk for 3.5 minutes while we're waiting for that spinning ball. So I'm going to do it all at the end when I can take some questions. The next thing I'm going to do is, so we've developed the task flow. We've developed a couple of features. And these are based on data that will be created or will be running from the JVM on device. What's much more realistic, I guess, is that data would be coming from a remote service. Okay, So I've got a service here. Just check it's all up and running. There we go. So if I take that and copy that, what I'm going to do now is build a feature based on that web service in the same way. And it happens to be, again, not particularly inspiring, but it's returning some information about regions in the world. So I'll go back to my feature, and I'm going to create another new feature. In fact, one thing that's maybe worth showing you now just while I'm here. I created this employees feature here, which was a task flow. One of the nice things that we have in this feature XML is constraints. I can actually define multiple pieces of content for the same feature, and then I can define a constraint on which page or which set of pages should be used. Now, where's that useful? Well, imagine I'm building an application that might be viewed by people on a small phone or a tablet. Okay? On a tablet, you could show much more information, so we'd maybe design a different screen. So what I could do here is actually design two sets of employees' screens and define a constraint that says if I'm on an iPad, then the feature will use this set of screens. If it's on a phone, these dimensions will use this. Similarly, it could be based on things like Android, or whether you've even got if you've got device features like a camera. Okay, so if you haven't got a camera, there's no use showing the feature which takes photographs. Okay, but let's go back, create another feature based on a web service. Let's call it regions. And our regions will create the content. And this will just be a single page. I'll create the page. Region. Okay. And again, just set the header up. Okay. So now I've actually got to create this data that I want to put on here. So again, let me go through here and create new REST service description. Give it a name. And then I can test that web service. Okay. So if I look down here, you'll see the raw content of the web service has been called, and it's basically a JSON object with a bunch of country regions. Dead simple. So what I'm going to do is say, well, that get method is the one I want to expose as a data control because it's somewhere in my application I need to show a list of regions for whatever reason. So I can do this and copy it. And what I'm doing here is actually creating a kind of copy of a client API, if you will. Now, I don't need this last part because I'm going to actually call it something specific. So get regions. Okay, and having done that, now get regions doesn't require any parameters or anything. If it was something that required parameters, then I could set them up here. But it's a very simple get, and it returns a list, no parameters required. So at this point, this is where I now generate out a Java, a Pojo, a client to basically call that get regions. So I'll just go through the wizard here. I create a connection to my web service, my DevOps connection. And just choose the method I want, which is getRegions, and OK. So what we've done is we've created a bunch of Java classes, which is the key thing that we really need out of this is this call, which will just do a getRegions. Now, as I did with my employees Pojo, all I need to do is wrap this up in my data components or data control, call it REST service, that's as good a name as any. And there you can see REST service appears pretty much the same way as employees, even though there are essentially data coming from very different sources. One's a straight POJO, one's a REST service. So having done that, I can go back to my region AMX page. I can look at my data control. Let's give myself a little bit more space. Let's go to the REST service, regions, and let's drag that on. And just as we did before, we can choose how that's displayed as a list. Let's have it with 2 items displayed. The main text we can make as name and subordinate text ID. We'll just take the default. And that's it. Okay. So what I'll do is I'll run that now. And we can do it to 6. Okay, and through the magic of a few minutes or so, that will take that application, package it all up, package up a JVM as a native iOS code line, and deploy it to the Android, so the iOS simulator. Now, for the sake of the demo here, everything I'm doing is based around iOS, but equally, I could generate out an Android application at this exact same point. I can generate out to the emulator, the simulators, or I can generate it directly to a device, or I can generate it to one of the package files as well, and then distribute it through the App Store, whatever you choose to do. While this is running up, the other thing I'll show you briefly, rather than do it in the demo, is we come pre-canned with a number of methods we expose in the data control for doing device integration. So I mentioned here are the device integration things for things like taking a picture. Okay, so we can drag and drop that on and bind it to a button to take a picture, just as we bound and drag and drop data with our employees or our REST service. All happens the same way. Send SMS, etc. We also have these application features that do things like getting a feature, navigating between features. So if you want to programmatically force the user to move from one feature to the next, again, these are the kind of common device-specific things you would probably want to do, and we expose them through the data controls, exactly the same way as your business logic or methods would appear as well. Okay, so there we go. There's our employees' data that's coming from a POJO. If I go to, if I move this up very slightly, or you can just see in the bottom anyway, here's our different features. And if I go to graph, there's a graph it created with employees feature. Down here, here's our help system. And if I go to this third one, this should be calling the REST service and getting our data back from a REST service. Okay, so that's three, I suppose, you've seen three different sources of application content. There's been straight HTML, absolutely simple what I was doing there, but could be much more complex. The more typical example is how I got data from a REST service. I just created a REST or Java client and then created a data control on top of that. Or local logic written in Java, exposes a POJO and a data control. We did that the same way. The navigation, as I showed, hopefully was quite simple. That could be tied up in your task flow, moving back and forward between these. And device integration, if I was to do that very quickly, if I go back to our, let's close a couple of these down, our math feature. and just create one more feature called photo. Let's call it photo. And that one will create just a single page. And for that one, if I look at my data control panel, and if I wanted to take a picture, device features, here's get picture, and I would just drag that on and bind that as a button. There's a couple of parameters I'd have to set up. So image quality is 50, destination type 1, which is file, source type 1, which is camera. Allow edit, true. Encoding type 1, which is PNG. Target width 200. As well. Okay, and then the actual image itself we dropped on there as an image. And that's an example of the device integration side as well. So whilst I know we all love to code, and there's certainly plenty of opportunity to building lots of stuff here, we're also trying to make things fast and productive as possible, and certainly a lot of the repetitive tasks, like designing page navigation. Again, the fact that you can sit down with users is quite a nice feature of this as well. I think it's a big advantage. And just to, again, reiterate, what you've seen there is the AMX features, which was the UI components. Again, I showed you a list and a graph, but there's much more exotic things you could have. We have things like timeline components, other data visualization. The controller is a task flow that you saw, and we called out to a remote web service as part of the data, as well as having client logic in our JVM. Accessing data from the SQLite database would just be JDBC calls wrapped in those data controls as well. So getting a list of employees from your local SQLite database would be exactly the same way in terms of binding that to the user interface. This here is our interface into the device features using Cordova plugins as well. And there's also a number of things that I wouldn't cover today, which is things like configuration services. So you can actually dynamically change, for example, where your servers are running or what servers you're running against. For example, you deploy your application, you want to run a test environment, and then you're happy with it. You can change the configuration and run against a set of production servers, for example. So I hope that's given you a little bit of an insight into what we're trying to do here with building mobile applications. You've seen me using OPI. We covered JDeveloper as well, and the development experience is the same right up to the point that I run that if you're deploying onto Android applications as well. There is a wealth of information out there. If you want to find out more, you can tweet me, GW Ronald. My team have also developed a whole bunch of videos, a whole complete training course on math as well. So if you want to pick this stuff up, use it for yourself, and maybe get a bit more time to look at the features on it, lots of videos on YouTube, and you can follow the usual social channels like Twitter and Facebook as well. I think I'm going to do questions the good old-fashioned way if anyone has any. So if you want, you can throw them up now. If not, I can be hanging about later if you want to speak to me. Any questions? Yes?
Have you got any names of people that are using this on the market?
Yeah, so if you go to the App Store, Apple App Store, and you Google on Oracle America, you'll find most of the apps there are math. There's also a number of case studies we published. I can only talk publicly about the ones, customers who have done that. But Lloyd's Register, the big shipping, are a math user as well. But if you Google on customer references, you'll see a whole bunch of customers using Oracle Math as well. Yes?
I've seen the whole statical REST code. It's possible also to deploy, to put some WebSocket and, let's say, streaming data as a stock exchange code also or something like that?
Yes, you can. And that was one of the areas where we kind of embraced the local HTML, because if you want to use more advanced options like the sockets and streaming, then you can do it through that as well. So yes, you can. It's less of the sweet spot of what we've got with the math, but absolutely you can still do that.
Suppose I have already done that on a desktop solution old-fashioned. So I have no whole socket, not just plain socket, plain communication. That's part of Java I can bring in this platform or not?
You could, yes. Yeah. Yeah. Yes.
Is there a runtime performance impact, or is it just the extra impact just at the build stage?
Good question. Runtime performance impact. Ultimately, you always have the situation, I've never defended that native development is the place where you can absolutely go to the nth degree in terms of performance. We found in about 18 months ago, Android was a little bit clunky with things like scrolling within its web view until it moved to Chrome. But that kind of stuff has been ironed out. It's more because it's not, to be honest with you, it's not just Oracle that's embracing the whole idea of these hybrid apps. It's quite a common approach. And so some of those rough edges that we maybe had 18 months ago with hybrid as a general thing are smoothed out. So yeah, generally you find that performance is within milliseconds of native, or can be within that. Yes?
What about the startup time?
Startup time tends not to be a big issue. We've seen about, I think ballpark about 14, 18 seconds, something like that for startup. Obviously it depends on where you're going to read your data, at what point you read it, but comparable to pure native, again, it's up there. Yes.
How do you do testing? Can you just test? Can you run it in a browser? Or how do you?
Testing's an area actually that we are doing a lot more work on. So we're kind of lightweight there. You can use some basic framework testing within OP or JDeveloper just with the Java stuff. But that's something we're actually partnering up with a number of other companies and partners at the moment. There's not much more I can say on it, but it's something we're looking at. Yes.
And you mentioned that the 16 megabyte runtime, is that for iOS or for Android?
That ballpark, that's for both, okay. For each one, yeah. As I say, there are licensing restrictions that we have to package it within the application rather than make it a separate runtime that applications would commonly use.
So do you hit the 64K method limit at times?
I'm not familiar with that.
The text method limit?
I don't think so. I don't know.
Okay.
Quite specific, yeah. Yes.
Are there any limitations? For instance, can you develop the iOS apps or Windows development platform, or do you have to have access to the XML?
Good question. So again, for licensing reasons, if you want to develop on iOS, for iOS devices, you must develop on iOS, on a Mac, for example. Here I can develop iOS and Android. On my Windows machine, I can only develop Android, and that's a licensing limitation that we have. That's why Oracle brought me a new Mac.
Yes, I understand.
I think it's time for one or two last questions. Yes?
Windows, the cutover, I believe it's able to target Windows Mobile as well. I think PhoneGap also built on it, targets Windows Mobile. Is there any plans to extend this to also target Windows Mobile?
Good question. So we're going to target Windows Mobile. Now, anytime I do a presentation with Oracle, we have a revenue recognition slide that says, anything I promise in the future, you can't hold me to. We are looking at Windows as a platform as well, and you can read into that as much as you can. But yes, we are looking at that.
It's obviously already got a lot of rich features, but if you come up against a really quirky use case and it's not supported out of the box, what are your options?
you can do that, but this is where we've actually seen some people do pretty. You guys will know it better than me that with mobile devices, you know, how slick user interface and speed and look and feel massively important. And we've seen a number of people who have said your UI components aren't giving us the look that our specific users want, and they've used kind of third-party libraries or frameworks as well to give different UI components and experiences, and that's completely fine. And Cordova also gives you that way to plug into external things if you want to do barcode scanning, beacons, all those kind of stuff as well. And that's completely supported. Okay. One last question, I think.
Are any parts of it open source?
Are any parts of it open source? No. Okay. Well, thank you everybody for coming along. Hope it's been useful to you.